Welcome to video uno. I'm Mr. Manga from the Congo. All right, so what are we learning today? Pretty simple. We are still diving into exponential growth versus decay. So today, think about it as a simple, additional to what we have been learning. The only new thing is this. So far, we have discussed that A is the initial value, right? And when you write the equation, we had the 1. Now, here's a different thing that I need to emphasize. When we have the minus inside of the parentheses, we're subtracting is due to a decay. So this will be a formula that we will use for exponential decay. When you have a plus inside the parentheses, this time you want to guess? Think, growth. All right, so we have a decay, we have to use a minus inside. We have a growth, we have to use the plus. Everything else is the same. A is for the initial value. This whole thing inside, we refer to the decay factor, and the T is the time. Same thing here. A is the initial. The whole thing is decay, growth, time, and R is the rate. Let's put everything into work. Let's put that into perspective. Here we go. There's numero uno. In 1985, there were 285 cell phone subscribers in a small town. So you already know the initial value have to be 285. That's our beginning value. The number of subscribers increased. We say increase most likely because it's increased. We're dealing with the growth value, okay? So that kind of tells me already that I'm going to have to use this equation right here, 1 plus the rate raised to the t value. All right, so remember, the rate is right here is given to us 75%, but we always want that a decimal, so you're going to have to divide that by 100, so your rate is really points. No, not point. Duh. Excuse me, ladies and gentlemen. I'm just going to erase that. You just divide that by 100. You should have 0.75. That is what we will use as a decimal. All right, and then it says it's after 1985, but really the question is how many cell phone subscribers were in 1994? So we have to go from 1985 to 1994. So you go from 1985 to 1994. That's approximately what? If I add 10, that will be 85. So that's about 9 years, right? All right, so let's go put this into work right here. Boom. So the A value is 285, open parentheses, 1 right here, plus the rate. The rate is 0.75, and the time we have agreed the time to be is 9. And all you have to do is put this whole thing in decimals. So if you just want me to do that, I can do that real fast for y'all. 285, open parentheses, put the 1. Since we're doing growth, you put plus, and we say 0.75, close the parentheses, raise that to 9, and the answer is 43,871. 43,8, for some reason, 43,871 point something, right? Since we're dealing with 0.98. All right, number 2. That was number 1. Not too difficult, was it? Yeah, I didn't think so. Number 2, because we did all this stuff already. You drink a beverage with 120 milligram caffeine. So most likely that is your A value because you started with that, my initial value. It says each hour the caffeine in your system decreases. That right there should tell you that we are dealing with a decay. So the terms that you will see may not necessarily be increase, decreases. They just might use different words for you to just know that it's going down, it's decreasing. About 13%, that's your rate, 13%. But don't forget to divide that by 100, and that should give you 0.13. And how much will you have left in your system after 4 hours? Okay, so since we're using decay, we will have the 1 minus R raised to the T. The A value is 120, open parentheses, 1 minus your rate. Raise that to 4, right? 4 hours 4. Put that in your calculator. And that will be the answer. In your calculator, you go right here, you do it. I think it's 120. Open the parentheses, 1 minus 0.13, close the parentheses, raise that to the power of 4. So the answer is 68.75. So just make sure you round this stuff correctly. I may not be looking at it carefully, but you, as of now, I'm not, but make sure you do it correctly. All right. All right, last one, number three. Number three says the following: the bear population is decreasing. Let's use a different color since this is number three. Which one should we go with? How about green? Let's do green. Okay, let's continue with that. So decreasing is decay. All right, at a rate of 2. So we have the rate of 2%, but in decimal it'd be 0.02 because you just divide that by 100. And then there's 1573 bears accounted for this year. Whoop, that would be my initial value. So let's write that in the equation. So you have 1573 open parentheses 1, because when you do decay minus our rate is 0.02. Raise that to 14 years. Put this in decimals, you get the answer. I don't have to do that, but you should know how to put that in decimal because I just did it previously. You did some last week as well. All right, that's pretty much it. This video, the practices are right here for you. All you have to do is click here to take your skill check first. So skill check is over the stuff we have covered of growth and decay. After that, you're going to click here to complete your practice. And yes, ladies and gentlemen, I'm taking it for grade. If the link for the skill check doesn't work, you can always find it on Canvas. Any question? No question. All right. Just like that, we're done.